The Reality Check wants to thank our sponsor, HelloFresh. Forget takeout, HelloFresh delivers all the ingredients for delicious, healthy meals anyone can prepare at home in less than 30 minutes.
My girlfriend and I recently tried out HelloFresh meals and thought they were delicious and convenient. As we are expecting our baby girl in a few months, we don't expect to have a ton of time to dedicate to making meals. A service like HelloFresh is an ideal time saver to allow for quick, nutritious meals without sacrificing quality. Go to hellofresh.ca and use promo code REALITY50 to get 50% off your first order.
This is your reality check.
Hi everyone, welcome to The Reality Check, the weekly Canadian show that explores a wide range of controversies and curiosities using science and critical thinking. This is your show for Tuesday, December 20th, and I'm your host, Darren McKee. With me, as usual, are Adam Gardner.
What's up, Cuboids?
Christina Roach.
Hello.
And producer Pat.
Hi, everybody.
But not as usual, we have special guest, Lars.
Hi.
We have a great show for you today. Pat is going to look into whether there are more trees on Earth than stars in the Milky Way.
Oh.
And I'm going to talk to you about snowflakes. Yeah, that's right, snowflakes. It's winter. But first, our special guest Lars, who has a background in economics, is going to discuss barter, money, and credit. Or is it the other way around? Lars, please illuminate us.
I'd be glad to. The origins of money is something that will likely always be mysterious. We know there was a time before money, and we know more or less what an enormous role it plays in our day-to-day lives today. But how and when did that change happen?
Good question, Lars.
Thanks. Typically, economists will try to work backwards. They'll say credit comes from money, money comes from barter. If you try to probe and dig for more detail, they'll say something to the effect that we have digital money and credit cards and paper money, and all of that can be traced directly back to gold and silver coinage. Metal coins themselves, they reason, emerged out of trading in precious metals at a time when all goods were exchanged for other goods. Mm-hmm. The theory was popularized by Adam Smith, who wrote a version of the story in his 1776 magnum opus, The Wealth of Nations. He argues that primitive peoples specialized in different productive tasks, made surpluses, and then traded those surpluses for other products that other people made, adding that the process would be inefficient or clogged and embarrassed, as he put it, because some people will inevitably have what you want, but you won't necessarily have what they want. Even modern economics books today repeat and update the same story. This is from the 2012 edition of The Economics Book, Big Ideas Simply Explained. They say, quote, "Without money, people could only barter. Many of us barter to a small extent when we return favors. A man might offer to mend his neighbor's broken door in return for a few hours of babysitting, for instance. Yet it is hard to imagine these personal exchanges working on a large scale. What would happen if you wanted a loaf of bread and all you had to trade was your new car?" Barter depends on the double coincidence of wants, where not only does the other person happen to have what I want, but I have what he wants. Money solves all these problems. There is no need to find someone who wants what you have to trade. You simply pay for your goods with money. The seller can then take the money and buy from someone else.
I think the loaf of bread and car is a great example. I could give you a ride in the car.
Looking through my own collection of economics textbooks, it's not hard to find the same story with almost the same wording. This is from the 2008 fourth Canadian edition of Principles of Macroeconomics by Gregory Mankiw et al. He was the economic advisor to former President George W. Bush. And he says, "Imagine for a moment that there was no item in the economy widely accepted in exchange for goods and services. People would have to rely on barter, the exchange of one good or service for another, to obtain the things they need." It goes on to describe an exchange of a car wash for access to a recipe. And then states, an economy that relies on barter will have troubles allocating scarce resources efficiently. In such an economy, trade is said to require the double coincidence of wants, the unlikely occurrence that two people each have a good or service that the other wants.
It's strange because I keep hearing double coincidence of wants, and to me it just seems like an argument against this bartering ever really happening.
That's a very good point, and a good premonition also. That it gets even deeper, though. There's even a catchy Schoolhouse Rock song that is all about how money and exchange all started out with barter. And there's a link to that in the notes.
Could you sing us a little bit of it?
Not that I want aired.
Notes at trcpodcast.com.
Although Smith undoubtedly popularized the theory, we can find its origin in the political writings of Aristotle from the 330s BC, which is about 300 years after the invention of coins. Aristotle wrote, quote, "The builder has to get the shoemaker's product from the shoemaker, and he has to give some of his own. Now there is an analogous equality, and each gives what he gets, and what we have spoken of will come about. But if not, the bargain is not equal, nor does it hold, for nothing prevents one person's product from being worth more than the other's. So they have to be equalized. So all things that are exchanged have to be somehow comparable. For that purpose, coinage came about, and it became a sort of medium, for it measures all things, so that it also measures the excess and the deficit, how many sandals are equal to a house or to food."
That's often how I measure my house, in sandals.
Oh, yeah.
Again, of course, it didn't occur to him that people never actually traded sandals for houses, but
Right.
I digress. An expert on ancient coinage and the origins of money named David M. Shapps writes that, quote, "Aristotle's description is of a piece with the best of Greek science. Plausible, explaining the unexplained, fitting the well-known facts, and wrong."
Ancient Greek slam!
It gets even worse. Carolyn Humphrey carried out an enormous anthropological study on various economic systems for Cambridge University, this around 1985, and she found out that, quote, "No example of barter economy, pure and simple, has ever been described, let alone the emergence from it of money. All available ethnography suggests there never has been such a thing," end quote.
Wow.
So that means looking back at ancient archaeological records, ancient texts, as well as current and ancient anthropological studies on various tribes, not a single example of a barter economy could be found. Instead, surprisingly, all of the non-monetary economies observed used intricate forms of credit, gift-giving, and using social currencies, such as objects of high value appropriate for dowries or ceremonies, but useless for purchasing market goods. A more objective history of money would admit that, at least in the case of metal coins, it evolved in 3 different cultures nearly simultaneously around 600 BC, namely China, India, and Greece, all of which had their own credit systems and social currencies, but none of them practiced barter on a significant scale. Ancient Greece is the most well-understood case, and scholars have demonstrated that the origin of money there evolved out of communal redistribution of sacrificial feasts. The Greek word for the smallest denomination of money is oboloi. I'm sorry, I'm pronouncing it wrong, but it refers directly to a handful of metal spits on which sacrificial meat was roasted. Then city-states gradually substituted meat for pieces of metal, but made sure that they were of a uniform size and purity to make sure that all the citizens got an equal share. To that end, the coins would be stamped with symbols of the polis, like the famous Athenian owls.
So the first pieces of money were chunks of meat?
Not exactly.
Okay.
The chunks of meat would not be used as money. The ancient Greeks used something more like cutlery as a kind of a market,
Okay.
pocket change kind of currency. But when metal coins were used as donations to the temple and then were redistributed to citizens from the temple, then they worked their way into the markets.
Okay.
So again, not at all like what Barter would predict.
No.
Yet the myth persists, and even has some defenders. One reason for that is that even though no economy has ever been found that can be called a barter economy, there are still plenty of examples of barter that we can point to. Some general rules about barter are that it tends to only occur between strangers, and to also involve a lot of ritual. Though even then, barter is never the dominant form of exchange, and is always subordinate to the complicated credit relationships that exist within tribes. It is also never associated with the rise of money.
Oh, snap.
Someone like George Selgin of the Cato Institute wrote a 2-piece essay criticizing David Graeber, the author of Debt the First 5,000 Years, and the man who is arguably the most famous for challenging the myth of barter in recent years. Selgin defends the myth of barter by arguing that, quote, "The mere lack of historical or anthropological evidence of past barter economies is itself no more evidence against Smith's account than it is evidence in favor of it. After all, if barter tends to get clogged and embarrassed, as Smith maintains, we should not be surprised to find no evidence of societies that relied on it. The lack might only mean that societies either came up with money quickly or perished equally quickly. Instead of refuting Smith's theory, in other words, the lack of evidence of barter may simply reflect survivorship bias." Selgin goes on to say, While subtle forms of credit or outright gift-giving may suffice for effective exchanges within tightly knit communities, exchange within such communities hardly begins to take advantage of opportunities for specialization and division of labor that arise once one allows for trade, not just within communities, but between them. That is, for trade between or among strangers. His argument, in my reading, amounts to little more than saying that there is no evidence of a barter economy, but maybe it existed and led to the creation of money anyways. Instead of Smith's vision of development within a community, it must have occurred between strangers, since that is essentially the only kind of barter that actually has been observed. I think that for veteran skeptics such as yourselves, some red flag should already be rising. This seems like a barter of the gaps argument. I should add that those who wish to defend the myth of barter tend to come from a particular political ideology, and the implications can be severe. If using money is just another form of barter, then it becomes easy to argue, for example, that minimum wage laws restrict the freedom and liberty of employers and employees to buy and sell labor on whatever terms they wish, when a different lens would see that there are important information and bargaining asymmetries. This myth is also popular among those who want to limit the power of central banks or return to the gold standard, and argue that even a 2 to 4% inflation rate is tantamount to debauching the currency. So, whatever your preferred narratives, you should at least try to rely on the most well-established facts. And in this case, that means you should not have any truck with barter.
Take that, barter, as the origin of money. Good stuff, Lars. I think the Cato guy's point about survivorship bias may be true, because we don't know. And if Barter didn't write things down, then you wouldn't have evidence of it. But I think it's pretty sneaky to say no evidence counts just as much for or against something, when that's obviously not true. Because I bet if there was evidence, he'd like, this counts just as much against it. Yeah, right. And now we go from the economical to the astronomical and arboreal. Pat, are there more trees on Earth than stars in the Milky Way?
All right, guys, how many times do we start a segment with the following statement? An image is making the rounds on social media. So last week I saw on my newsfeed a pretty picture of a clear night sky with the Milky Way visible. A reverse image lookup suggests it was taken at Bryce Canyon National Park in Utah. Below the image is the following text. There are more trees on Earth than there are stars in the Milky Way galaxy. What does everyone think of that statement?
Please quantify the statement. Are we talking about visible stars? Or what the hell?
So, we're the approximately 200 billion range? Are there 200 billion trees on Earth? That's actually plausible. I actually don't know.
I don't know.
Yeah, well, once you get to like 2 orders of magnitude higher than 10, then all big things look the same to me.
Here's $1,000. Here's $1 million. Okay.
Yeah.
Says the economist.
If it's on paper, it's easy.
Yeah.
So the image also has a URL, unbelievableFactsBlog.com. So that seems like a pretty good place to start digging into this. From the About section of that site, this blog contains verified, mind-boggling facts that has been, rather than have been, collected from various sources all over the internet. In case, all one word, any doubt, you may click on the source mentioned below the post. Okay, the spelling and grammar errors aside, it's pretty refreshing that the website has sources included for the statements made on every image on their site. And they have a lot of images on their site. Now, I can't speak to everything that's been posted there, but the sources for the first few random images I looked at, they actually seemed pretty reasonable. An article at Time Magazine, a decently written Wikipedia article, and a PBS article. And then there's our image about trees and stars. I'll admit it, like some of you, I was a little bit skeptical of the statement about more trees than stars in the Milky Way. So I was surprised that their source for this image was an article titled Trillions of Trees in the science journal Nature.
Oh,
Trillions.
Sorry, what journal? Never heard of that one.
Is this one of those fake news things?
You're like naturenews.com?
The article discusses a study by scientists in 15 countries led by Yale forestry researcher Thomas Crowther, estimating the number of trees on Earth. The forest density study combines satellite imagery with data from tree counts on the ground that cover more than 4,000 square kilometers. The resulting paper, titled Mapping Tree Density at a Global Scale, provides an estimate for the number of trees on Earth. 3.04 trillion.
Wow.
And that's more than 7 times what we previously thought based on estimates for the number of trees from a 2005 study. So on to the second part. How many stars are in the Milky Way? First off, both the number of trees and the number of stars are estimates. They're impossible to verify. I link in the show notes to an article at space.com on how the number of stars are calculated, but basically it boils down to estimating the mass of the galaxy. The mass is estimated by looking at how the galaxy rotates, as well as its spectrum. The tricky part is figuring out how much of that mass is actually stars as opposed to dark matter. Some estimates suggest that the Milky Way has a mass of about 100 billion solar masses, so it's easiest to translate that to 100 billion stars. This accounts for stars that would be bigger or smaller than our sun and averages them out. There are, of course, other estimates, some going as high as 400 billion stars. NASA education and outreach specialist Maggie Massetti agrees, saying that most estimates put the number of stars in the Milky Way at between 100 billion and 400 billion. So based on these estimates, then, the statement in the image is true.
Wow.
Boom.
There are more trees on Earth, 3 trillion, than stars in the Milky Way galaxy, so long as no one develops a new method to count stars that yield a much higher number than the current estimates.
Or a new method to count trees, which reduces them.
Right.
Or if we just cut down some trees.
Progress.
So is this good news? Well, sort of. There are more trees than we thought. However, here's a quote from the study. Based on our projected tree densities, we estimate that over 15 billion trees are cut down each year. And the global number of trees has fallen by approximately 46% since the start of human civilization.
Wow.
As we know, deforestation can have many negative effects on the environment. The most dramatic impact is a loss of habitat for species. It's estimated that 70% of Earth's land animals and plants live in forests. So there you have it. This one's true. It seems there are more trees on Earth than stars in the Milky Way.
Cool.
I love it when one of us comes across something like that and you kind of go, what? And you really don't think it's true, and then you dig in, and very cool.
I know what you mean. I've been hurt before.
I need to learn to trust again. Hello, science.
This gives me some good hope for the possibility that there might be like an Ewok village out there, something like that. One of these forests.
Oh, Adam.
Well, more so than trees or stars is the amount of snowflakes that fall in wintertime.
Is it? You want to back that up with some science? Yeah, you're probably right. I rescind my criticism.
Because each of our listeners is a beautiful, unique snowflake, and given that snow is a Christmas staple, I thought I'd take a few minutes and tell you about snowflakes. Yeah, that's right, snowflakes. Mm-hmm. First, what is snow? Well, a form of precipitation, like rain or sleet. And by the way, sleet is actually tiny rain particles that freeze on their way down. Snow occurs when water vapors in the atmosphere freezes into ice crystals. The temperature in the clouds have to be around minus 35 degrees Celsius or minus 32 degrees Fahrenheit. Snowflakes are made up of crystals of ice that have formed around bits of dirt in the air. The snowflake starts out very small and grows. Each snowflake is different and might contain up to 200 crystals. That's the simplified version I found on easyscienceforkids.com, because we're all a kid at heart.
I'm surprised it's that cold, because it usually seems to snow in the close to 0 Celsius range. But
It's
I
colder
guess because it's so much higher up.
Yes,
Right?
exactly. There you go. That's the easy version, but I felt there was a more interesting one on Wikipedia that was pretty cool. No pun intended, believe it or not. So first, there's a simplified Wikipedia version.
Oh, yeah.
Snowflakes nucleate around particles in the atmosphere by attracting supercooled water droplets, which freeze in hexagonal-shaped crystals. Mm-hmm. Okay? Mm-hmm. Now, the more detailed version, which is going to say the same thing as I said twice before, but with more detail. A snowflake consists of roughly 10 to the 19 water molecules. Yeah, you got your trees right there. Which are added to its core at different rates and in different patterns, depending on the changing temperature and humidity within the atmosphere that the snowflake falls through on its way to the ground. By the way, I'm just reading Wikipedia right now. Consequently, they are different but have similar patterns. That was not Wikipedia. Snow crystals form when tiny, supercooled cloud droplets, about 10 micrometers in diameter, freeze. These droplets are able to remain liquid at temperatures lower than negative 18 degrees Celsius, because to freeze, a few molecules in the droplet need to get together by chance to form an arrangement similar to that in an ice lattice. Then the droplet freezes around this nucleus. So you have really, really cold water that's actually far below freezing, but it's at such a molecular level, it's not making ice yet. Once a droplet has frozen, it grows in a supersaturated environment, in this case meaning one where the air is saturated with respect to ice when the temperature is below the freezing point. The droplet then grows through water molecules in the air, which is the vapor, moving onto the ice crystal surface where they are collected. Because water droplets are so much more numerous than the ice crystals due to their sheer abundance, the crystals are able to grow to hundreds of micrometers or even millimeters in size at the expense of the water droplets. Water droplets are becoming ice crystals, and that's why the ice crystals are growing. The corresponding depletion of water vapor causes the ice crystals to grow at the droplet's expense. These large crystals are an efficient source of precipitation, since they fall through the atmosphere due to their mass, and may collide and stick together in clusters or aggregates. These aggregates are snowflakes, and are usually the type of ice particle that falls to the ground. Now, that's snowflakes itself, which is pretty interesting, and although ice is clear, scattering of light by the crystal facets and hollows or imperfections mean that the crystals often appear white in color due to diffuse reflection of the whole spectrum of light by small ice particles. This is the idea that snow is not actually white, quote-unquote, it's clear, but because light is bouncing around so much and reflects back, we get the illusion of white light.
I'm just looking at it right now. It looks pretty white. But,
I know.
yeah,
so that's why, like, the sky's not blue. You're like, yeah, okay, but to my human eyes, it is.
Yeah.
Yeah, whose perspective is it clear?
on the macro micro scale that we live in, you know, it's pretty white.
I'm dreaming of a clear Christmas, which looks only white because of the diffuse spectrum in your human vision.
I guess like if I had like a pool full of diamonds that I could swim in, like Scrooge McDuck style, if that wasn't impossible, it would probably look white. And really friggin' shiny.
If those were cut diamonds, though, I wouldn't recommend swimming in it.
No, I mean, it would be differently impossible than swimming in this muddy bin, and more deadly, potentially.
So that was about snowflakes. I thought that was really neat to get some of that basic science. And now just some fun facts about snow and snowfall. The heaviest snowfall recorded in the U.S. in 24 hours was in Silver Lake, Colorado, back in 1923. And it accumulated a massive 193 centimeters, or over 6 feet.
Wow.
6 feet of snow in 24 hours.
Wow.
The largest snowman ever built was 122 feet tall. It's built in Maine in 2008. While the largest snow sculpture ever built was also in 2008 in Heilongjiang province in China. It was 656 feet long and 115 feet tall. It took 600 sculptors from 40 countries to build it.
But can you see it from space?
No problem. And finally, not every big snowstorm is a blizzard. In order to be classified as a blizzard, a snowstorm must meet a very specific set of qualifications. Winds must blow at least 35 miles an hour, and the snowfall must reduce visibility to less than 0.25 miles for a period of at least 3 hours, which is pretty precise. Mm-hmm. And these various facts were taken from a Mental Floss article, as well as the Easy Science for Kids, which is linked in our show notes at trcpodcast.com.
Great website.
Now, Darren, you sort of alluded to from the kids article that no two snowflakes are the same. Is that true?
Just today I saw an episode, or a clip of Adam Ruins Everything where he says that there was a scientist who found two identical snowflakes, but it was a digression, so he didn't go into detail.
You suppose that happened in like 1983 or something like that? But I think generally speaking, it depends on the molecular level.
Yeah.
Right? We talked about that in a previous episode where at a larger scale, there's about 200, I think, classifications of different sizes, and there's all these terms which I've never heard of that classify shapes of snowflakes and how they come to be. But at a molecular level, it is not quite the case. So it depends on your level of zoom.
Okay.
So I would say, and one level, yes, you can find snowflakes that are very much alike, and another level, not quite.
You could also say, like, there are no two raindrops that are identical, because when you can get down to it specifically, there's going to be a minor fluctuation that you would never perceive with your eye.
I mean, and we could say atoms, for the most part, are the same. Hydrogen atoms are treated as interchangeable. Is the electron cloud around it exactly the same?
Yeah.
What does that mean? Probability, quantum theory problems.
What's the wave function of this particular hydrogen molecule or whatever?
Thanks for joining us once again, and thank you, Lars, for coming on the show to talk to us about how barter seems to be highly unlikely to be the origin of money as we understand it, despite what many economists and popular thinkers will say. And that Pat showed us that there are indeed more trees on Earth than stars in the Milky Way, according to current estimates. Well, I explored the nature of snowflakes and tried to give you a bit more scientific background on it. Christina and Pat will be doing the holiday parody show for next week, so some of us here will not see you until the new year, and I just want to wish you well and say you can be that annoying person over the holidays that tells your friends snow is not white. Until next time, think better to act better.
Merry Q, boys.
Happy holidays, everyone.
Happy Festivus, and what we would love for Christmas is a 5-star review on iTunes.
Good call.
Good night, everyone.
For show notes, or to discuss this episode, visit our Facebook page and website at trcpodcast.com. For general inquiries, or to send a topic or parody suggestion, email info@trcpodcast.com. Help support the show by leaving a review on iTunes and liking us on Facebook. Follow us on Twitter at TRC_podcast.
Outtakes.
A snowstorm must meet a very specific set of qualifications. Qualifications. Let's try that again. Right. Finally, not finally.